I just had written down the answers here. It was in part 2, number like 7. It was number 7. Yeah. Sarah or Deb, did either of you do a sample mean for that one, or?
Oh, go ahead.
No, I was just going to say, I look at those a little bit, and if I understand it, I don't mess with doing them. So
Yeah,
okay.
That's what I do too. So I didn't do.
Okay. Okay, cool. That one just seemed like elaborate, so I was like, well, maybe I'll just in case somebody else did it. So okay.
That makes sense. I was doing the reading still, and I looked over this, but then I read the reading, and so I don't know. I didn't match them together yet.
Okay, yeah, no problem. I just did it just in case maybe you guys did too. So, okay. Should we start going through the quiz then?
Sure.
Yeah.
Okay.
Oh.
Yeah, go ahead. Whoever said that, I'm sorry. Go ahead.
Okay. When taking samples of n when n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed? And so I did that, and it skewed right for me. So.
I got skewed right also.
Yeah.
Me too.
Okay.
I'll do the next one. When taking samples of n equals 100, what is the shape of the distribution of means histogram when a parent population is right skewed? Sorry about that. And I have normal. You guys
Agreed. Yes.
I have a question on that. I looked all over the reading, and that was one of the ones that I could not find. I looked all over, and I didn't understand how to put n equal to 100 because I was on the tool. What's it called? The sampling distribution tool. And how do you do that? Because I was trying to put n equal, but the highest it would go was 25.
So
I looked at the wrong spot.
Yeah, so in the readings under section 5, it says review of key concepts. I just hold it up right now. It just says for this course, if n is greater or equal to 30, we will say the distribution of the sample means will be approximately normal.
Okay.
So anytime you see a mean bigger than 30.
I was just like, what do I do? So I just pushed the thing like 4 or 5 times and tried to get a sample.
Yeah, I didn't get that one either, so I'm glad we went over it.
Yeah, I was just like, what? Because I don't know, this one, it was not that difficult on an assignment, it really wasn't. But some things I just couldn't find in the reading. I was just like, where is that? I don't know how to, but it was the wording of it. Greater than 30 to me doesn't say 100. I don't know what's wrong with me. Okay.
Yeah, for sure. It was just in there, one sentence, so it was super easy.
Because that's exactly where I was right when you told me that it was under the review of key concepts. I was just like, well, that's where I was just reading. And then I was like, what? I just read that. So,
Totally.
anyway.
Okay, so I'll do number 5, or is that where we're at, right? Okay. When taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed? And so I got normal for that one as well because it's greater than 30, and then it's also normally distributed to start with.
I agree.
I did the same thing that I did on the last one. I just clicked on it a whole bunch of times, and it was normal on normal, so I got normal too.
You proved it.
Okay, I'll do the next one. When would the distribution of means be normally distributed? And I put data are drawn from a population that is normally distributed and the sample size is large. Is that what you guys got?
I have a few more.
Mm-hmm.
Oh, okay. I didn't see choose all the correct response. Okay. So there's more than one.
Yeah, I checked 1, 2, and 4.
I did too. Yep. And 4 was kind of tricky, but I believe that's right.
Yeah. And where did you guys find that one? Because I found I found two of those, but I couldn't find whether for the like I was pretty sure that 1, 2, and 4 were right, but I couldn't find where to disprove that 3 was wrong.
You couldn't find why number 3 wasn't also?
Yeah, I just didn't know how to disprove it. I didn't. I was looking for that in the reading as well. I don't know. Me and reading didn't get along very well this time.
Tonight. I don't know what it is. It must be me. But I didn't hear what you were saying.
Oh, I'm sorry. I said that I I didn't see it in the reading. A lot of the stuff in the reading I understood it, and it just didn't click when I read the question in the quiz with the reading. Like they just didn't connect.
Sorry. Okay.
Yeah. I would read it from the reading, and then I would read something in the quiz, and I was like, I don't remember reading that at all, and I would look all over for it. I've been doing 6 o'clock, and I just.
The first thing that I found that kind of backs that up is in section 2, under 2.1. The first bullet point says, if the parent population is normal, then the sampling distribution will always be normally distributed, no matter how observers are selected. And the next one says, if it's not normal, it will be approximately normally distributed if the sample size is large enough.
Okay. Yeah, I see that. Got it.
Yeah, it's just when they word it differently.
Okay. So since the sample size is not large, then it's not going to be normally distributed.
Right. So if the sample is right skewed to start with, or the population is right skewed to begin with, and then the sample size is small, then you're going to get a right skewed population also. All right. Sorry, I always mix up the words. The distribution of the means will be right skewed as well.
No, that makes sense. I read that stuff, and it's just like when you say it, then it makes so much more sense than when I read it, I guess. I don't know. I'm not realistic that. Because I'm just like, no, I read that. Why didn't that click? I'm not sure. Yeah. So that was the problem. I read through that thing a couple times, and it just wasn't connecting in my brain, I guess, with the quiz question. Word number 7, I'm pretty sure I got that one right. Which of the following gives the best explanation of the central limit theorem? And then I got, if the sample size is large, the shape of the sampling distribution of the sample mean X will approximately be normal.
That's what I put too.
Yeah.
Okay. Good. Because I found that in the reading. I was like, oh yes, I found one in the reading. Woo!
I'll do 8. Let X be a random variable with the population mean mu equal 10 and the population standard deviation sigma equals 6. Suppose a sample of size n equals 36. What is the mean of the distribution of sample means? And I have 10.
Now I just wanted to make sure, because I was doing this and I just wanted to make sure I was doing it right. So at the very end it has that it has the standard deviation divided by the square root of n. Is that what I'm doing? Are they doing that right? Or
I don't think you're quite doing that yet.
okay. Well, I did that one wrong.
Right here you're defining what the mean is. And it tells us up in the equation what the mean is.
Wait, what's the meaning of the distribution sample? This is that word? Sorry.
So if you want to look back in the readings, under section 3, the first bullet point says the mean of the sample means is mu, so it will always be the same as the population. So you just...
Okay. Okay, the mean of the sample means is mu. And then, how did you tell me?
So for number
Because
the
it says the standard deviation. Oh, that is the standard deviation divided by the square root of n. So that's the standard deviation. The mean of the sample is u, but what's the actual formula for that? That's where I was a little bit confused. Is
for number 8, right?
yeah.
You don't have to do a formula at all. You just, because it tells you mu equals 10, and so in that first bullet point is telling you, so when you're doing the sample mean, it just is exactly the same. The population mean and the sample mean are the same.
Hey, thank you so much. Okay, sorry.
Yeah, no problem.
Go ahead.
That's what we're here for. Is it me up now? I'll do this one. So we do sigma divided by the square root of n, and I got 1.00.
Yep.
Okay, I did that one right.
So, did you get 1.00 or did you take it out 3 decimal places? Because that is last week. How I got wrong?
Right. Yes.
Right. So make sure you have 3 decimal places.
Okay.
He was very good and went in and changed my grade and everything, but I left the directions.
Okay. It was 1.00.
0.
Okay, that's what I thought. Okay, so that's what I put. Yeah, I just wanted to make sure. I really got.
Yeah, thank you for. I read 3 decimal places as like counting the 1 for some reason. So thanks for telling me that.
Okay, I'll do number 10. Regardless of the distribution of the population, if the sample size is large and greater than 30, what would be the shape of the distribution of the sample mean? And I put normal.
I agree.
Okay.
Yes.
And then what theorem would justify your response to question 10? And I thought that was the central limit theorem, but I probably, oh no, that wouldn't make sense. It's large. It's the law of large numbers, right?
I put central limit theorem.
I did as well.
That's what I put the first time, but I was just like, n is greater than 30, so I was like, maybe? I don't know.
Does anyone understand the difference between those two really well that can explain it really fast?
Yeah, please.
Because I still get a little confused about the two of them.
Yeah, I keep having to go back to the definition every time too, so.
Okay.
Yeah, so
maybe I can try and come up with something.
Maybe he talks about it on those videos.
Okay.
Yeah, I'll just watch those.
That would be a good idea.
It's like it says the law of large number sizes. Oh, the law of large numbers states that as the sample size gets larger, the sample mean will get closer to the population mean. And then the central limit theorem says the distribution of sample means is normal when x is normally distributed, or when, thanks to the central limit theorem, our sample size is large. And I just need to. That's why I thought it was central limit theorem first, but then I looked back and I saw that it said n is greater than 30, and I got confused. Sorry.
You know, I also thought that the, are they called widgets or whatever, the little videos like that, I thought that he did a pretty good job explaining them too.
The linked thing, the one with the graphs, and yeah definitely. Okay, well, I submitted mine. It was all good.
Okay.
Perfect.
I don't know if you guys got my email, but there's a chance that I might be late or might not make it to our meeting on Thursday.
Yeah, I saw you.
Okay, would anybody mind just setting up the Hangout for me and on Thursday?
Is there anybody that already understands how to do that? I don't know how to do it, but I could try and figure out how.
I'll do it.
I mean, I can figure it out if nobody knows how to do it. I just didn't know if somebody already had experience and knew how to do it.
I just read the directions, and it can't be that hard, right, Alex?
super, super easy, and he does go through all the directions in that the Google setup thing.
Yeah,
So.
I saw that stuff. Okay, but then
You want to do it, or I'm happy to do it.
it really doesn't matter to me because I can I saw the instructions. I know where they are. I can follow this easily.
That's fine.
Okay, so I will set it up for Thursday, and then I just email it to you, right?
Yeah, there's a way to invite people, but do you guys ever get the invites that I send? I don't know how they are sent.
Log into my email and get your link, and then that's the fastest way.
Okay.
Yeah, but I've seen the actual link as well. I've seen both, but I usually use the email because it's fast. It's just like real quick, and the link takes a little bit longer because I have to find it. So yeah.
Okay, and then so just as a heads up, like when I start the Hangout, and then I just copy and paste the link from the top of it that you can see, and that's what I send to you guys, and it's worked. So
Yeah. So just like from the URL address, you just
Yeah.
copy and paste that. Okay.
Mhm.
And then as soon as we start, we just push record.
yeah, when everybody starts, then you just put start broadcast.
Okay. Awesome. I think I can do
But
that.
yeah, hopefully I'll be back here in time for that. But just in
Yeah.
case, I figured I'd make sure you guys can get started. So.
And then you guys know tonight that you have to make sure you go in after Alex posts or whatever on the discussion board. You have to also go in and say that you attended tonight. Did you hear that in his little YouTube?
Is it the brand new one? I haven't watched his brand new one. I watched
So make sure.
week 3 videos. Okay, I didn't even see that yet. So yeah, I need to take a look at that one. So we need to do what? We need to go on to iLearn and type in the reading.
So in the group, it says group collaboration, and it's a discussion board. So after Alex posts our video, then you just go in and you just say that you attended, and that way it triggers something for him so he can go in and grade it to give you.
Okay. Just on the group collaboration thing, you just put I was in the meeting. Okay. Alrighty, I will set up the Google Hangout for Thursday, and I will see you guys then. Thank you so much for explaining all that stuff to me. Sorry, I don't know.
Guys later.
Thanks,
Bye.
guys. See ya.
Thank you. Okay,
Bye.
bye.